I'm going to use the automated machine learning app that I built to predict how many strikeouts an MLB pitcher is going to throw in an upcoming game. We've got about 6,000 observations of historical data with some variables that we'll look into in a bit. And then we've got 6 pitchers for upcoming games that we're going to try to predict how many strikeouts they're going to throw. We can see how the various machine learning models did on the test data here as far as their performance and accuracy. But let's get into why the model predicts what it predicts and how it looks. So we can see the most important variables here in this top left plot. We can see that the pitcher's 5-game trailing strikeout average is the most important, which makes sense because their performance in the past will probably be pretty similar to how they're going to do in the upcoming game. The opposition's 5-game trailing strikeout average, relative to how many at-bats they have, is also pretty important. Days rest is the third most important variable. Months and quarter of the year is also pretty important. So let's look into why that is. First, let's look at how these tie into a breakdown of a given pitcher's predicted strikeouts for an upcoming game. We had 6 holdout pitchers that we want to predict how they're going to do. Let's pick number 1. This model is saying that the intercept, or the average, is 4.669 strikeouts per game, and that this pitcher's average is 4.1. So that's immediately going to drag down their predicted performance in strikeouts. The opposition's trailing 5-game strikeout average is about 29% of the at-bats they strike out. And the model is saying, well, that's pretty high, so that's going to make it more likely this pitcher throws proportionally more strikeouts. Days of rest is 5, which the model sees as positive for more strikeouts. Quarter of the year, early in the season, quarter 2, so between March and summer, has a positive effect. Month of the year, 4, being April, has a positive effect. So overall, we think this pitcher is going to throw more strikeouts than average, and they're going to throw 5.365 strikeouts, the model predicts. Now let's look at how these important variables for predicting strikeouts relate to the predictions. We can see the individual plots here, a scatter plot on the left from the training data, and we can see the average target versus feature plot on the right from the training data. The pitcher's trailing 5-game strikeout average has a positive relationship with how many strikeouts we predict they're going to throw in the coming game, which makes sense. How they do historically, we'll probably predict how they do in the future. If we look at the next variable, opposition's 5-game trailing strikeout average, we can see that opponents who have higher strikeout ratios, so this meaning 44% of the time they're going to strike out, that leads to a prediction of a higher strikeout game for the pitcher coming up, as opposed to when they face teams with lower strikeout averages. We can also see that days rest has a pretty unique trend here, where as they have many more days of rest, it is predicted that there is going to be lower strikeouts thrown by them. And that's kind of interesting. The way I'm interpreting this is that when a pitcher has over 400 days of rest, meaning it's not just their first game of the season or something like that, they may have been sent down to the minors for an extended period of time, meaning they weren't as good as MLB caliber players, or it could be that they are coming back from an injury or something like that. But in general, more days of rest is related to lower strikeouts thrown. Now we can see quarter of the year, where in early quarter, so between January and March, so spring training time, they tend to throw less strikeouts, and then when they get into the swing of the season, the strikeouts go up, but kind of plateaus and even goes back down as they reach the final quarter of the year where there's playoffs. When we look at months, it's going to show a similar trend because it's still that time of the year data, but it's just a little more granular. And we can see that plateau is much longer with that decline to lower strikeouts being essentially in just the last month of the year. That's how our model predicts how many strikeouts a pitcher is going to throw in an upcoming game. Hope you enjoyed it.